Hi, my name is Tracy Thomason, and I will be participating in Challenge 2009. Today, I'll be speaking about derivatives. Some of you may be wondering what a derivative is. A derivative is the slope of a tangent line to a given curve. In order to find the derivative of a certain function, you can use this formula. The derivative, also known as f prime of x, is equal to the limit as h approaches to 0 of f of x plus h minus f of x over h. We're going to use a simple curve, x squared, and find the derivative. We begin by plugging in x squared everywhere where it says f of x. We can go ahead and factor out the equation like normal. We can see that our x squareds cancel out. And we can go ahead and divide out the h's, leaving us with the limit of h approaches 0 of x 2x plus h. As we know, h goes to 0, which leaves us with 2x as the derivative. I will now differentiate the same equation using an even simpler method. This method is called the power rule. You apply the power rule by using this formula. And we will have 2 as our variable n. After you plug in using the power rule, you get 2x to the 2 minus 1, which of course cancels down to 2x, which was the same derivative from our first problem. As you can imagine, there are many different types of functions that are differentiable. To find the derivative of the sum of two functions, you can use the sum rule. To find the derivative of the difference of two functions, you can use the difference rule. To find the derivative of the product of two functions, you can use the product rule. To find the derivative of the quotient of two functions, you can use the quotient rule. Now we will move into some examples. The first step in differentiating a function is always to try to decide which method will be best. As you can see in example 3, we're looking at the sum of two functions, which means we'll be using the sum rule. As you can recall, the sum rule is f prime plus g prime, which means we can go ahead and differentiate each term individually. We'll do this by applying the power rule once again. We can go ahead and simplify. And this is the answer we get. Example 4 should be worked out in the same way. The only difference is the subtraction sign, which means we are applying the difference rule. The derivative of each term individually is still the same. Our answer will just have a minus sign. Moving right along, we have the derivative of the product of two functions, x times e to the x. And once again, the product rule is f times g prime plus g times f prime. We'll have x as f and e as g. We'll fill in for the function. In case you didn't know, the derivative of e to the x is just e to the x. And the derivative of x is 1. So our derivative simplifies to Next, we have a problem using the quotient rule. The quotient rule is g times f prime minus f times g prime over g squared. E to the x will be f and x squared g. And we will go ahead and plug in. This is the general form of our derivative, which can be simplified in many ways, but for time's sake, I will not simplify.